Oh, hey guys, I'm gonna wing another one here. Okay, here's what we're focusing on. Remember I told you that big planet crossed the ACE satellite at the L1 Lagrange position? And here it is. Here's L1. This is where the ACE satellite and Discover satellites sit, recording all the solar wind properties coming toward the Earth to give within a 15 minutes, 1 hour warning before it hits the geosynchronous satellites at the 22,236 mile mark. So anyway, okay, the big planet crossed ACE around October 16th because we weren't picking it up anymore in front of the satellite. Then we picked it up behind the satellite, as in gaps between ACE trying to relay data to the Earth stations. And that lasted for a week or so. Ever since then, it's been heading our way. And I've been highlighting all these interplanetary magnetic blue field lines. Those are only supposed to be mostly between the sun and the planets. And I suppose if the planets get close enough to each other, then it would be planet to planet. And I think that's what's happening here. Now, if you'll notice, see all these interplanetary magnetic field lines piling up down here? And look at the magnetopause. It's pushing out to, and see the polar cap field lines gaining strength and pushing out this way. They're all pushing this way to try to ward off this interplanetary magnetic field that's trying to get to the Earth. And that's the only reason this thing could be bowed out in this direction. And these are all the same time, C1116, 556. And then if you look at the solar wind speed, which is being measured by these geosynchronous satellites in here, it goes 13 and 14, and then the 15's in there as well. You see that the solar wind speed at that time within the magnetosphere, magnetopause area, is quite low. It's only 379, so there's nothing really bowing it out here, I don't think, although you do see some arrows pointing in this direction. What I think is it's just the planet reacting to this big planet that's in front of it. And if you notice, okay, you notice those, I made reference to these squiggly lines before. Those are interplanetary magnetic field lines. Obviously, they're getting broke by probably Earth's magnetic field. But you can see how many of them are out there in front of the planet. And then also I noticed that this bow shock has been getting pushed way out, and it's being pushed in this direction. So there's something out here also. Well, it's the same planet, I'm sure. It's just the different way that Earth's reacting to it. You see it's pushing way out. And you can see it on here. See how much room we got out in front of the Earth on the sun side? These things are reversed to the ISWA ones. So sun side's on the left instead of on the right on what we were just looking at. And notice how much it's bowed out here. It's trying to, it's reacting to that planet that's out in front of the Earth. And as you can also might notice, the pressure is pretty low on both sides of the planet, so things are getting kind of equalized again. Now, I think there's still a lot of pressure, but it's just being equalized. That's why you don't see it representing in these deep reds and oranges. So we had some pretty heavy solar wind speeds during this run. Take it back, I think. Yeah, okay, that's when it first started. 2016 54, 2011. This is 11:15 yesterday. 2020 UTC. So we had 11:45. This is all being measured inside of here. Kilometers per second. 1181. Then went to 752. You see all the arrows are going this way. Trying to, well, they should be going that way. There's some plasma being ejected. 612, 558. See, they still got a lot of plasma, a lot of instability with the field, with the arrows moving around. Watch the arrows. Watch the wind speed. There's 884, 810. So where we got some more there, more plasma being ejected. We got a bunch of plasma piling up around the planet. 914, 7 cents. So that was pretty high all through there. Then we had a little bit of a lull. Then we got another one. 906. Still got a lot of plasma. Arrows are all screwed up. 1037. There's 1388. I think that's the highest one in this run. Look at that. It was a big oomph to get rid of all that plasma. So let's see what happened over here. I think 1520. That's when it first started to get weird. But look at here, way back at 1115, 1808 UTC. Look at all these black polar cap field lines that normally just stream away from the planet. Look how they're getting all closed up and balled up. In other words, they're making a connection back to the Earth. And this is being pushed out well beyond 100 Earth radii, which is 4,000 is 1 Earth radii. So that's well beyond 400,000 Earth radii. This thing's pushing, getting balled up to push all this energy out. Well, let's see how it looks at 11:15, 22:28. And watch the blue line, watch everything. I mean, it's crazy. And hopefully I'll have enough time to just let it run through on its own. You can watch it. There's another big, there's 11:15, 2020. I think that's when, that was when we got the first wind speed. Around 10,000. There's 2024. Ooh. Pretty long duration event. It's still 28 minutes. And it's still going wackadoodle. Still wackadoodle. It's a whole hour. Remember, it started at 11:15, 2020. Now we're up to 11:15, 21:20. The black field lines are very black, very dark. I think they're gaining strength from this planet here. So see, we got an open area, so maybe this magnetic energy is coming directly into the planet and strengthening these black field lines. That would be my hypothesis, because they needed to be strengthened after being closed for so long and having to expel all that energy. So there we are. That's a full 1 hour into that event. Where are we going? 22:28. And we got another rejection. So there's 22:28, 1388. So this is a pretty long event. It started at 2020 with the high wind speed. 22, 24, 2300 UTC on the 15th. Still, we got some major instability. And then I guess it started going back to normal around, probably around 2320 when it got rid of all this energy finally. Let's see what it looks like here. So there's 417, 387. So the solar wind speed came down right after 2020, but then it came back up again. 9, 8, 1037. Then we got 1355. 1388. Yeah, that was the one we were focusing on, 1388, 1355. So 1084. So we're up to 2320. Let's move this along. So the solar wind speed's quieting down. 2320. And we keep pulling it along. Watch the solar wind speed. There's another ejection. Oh, there's a big ejection there. I don't see any missing time. There's 1022. So we're having another high solar wind speed event inside, close to the Earth. See all the plasma. It's broke up. We still got a whole bunch of it around the planet. 1022 again. 1095. Then I think for the rest of this run, quieted down solar wind speed. So it started at I would say the event started at, and what was it, 11:15 2020, and we're into like 11:16 124. Let's go back and look. Yeah, so there was nothing before that. There it is. 2020. So that was about a 5-hour event with strong solar winds. So that's when it finally got rid of everything and everything started lining back up, it looks like there. But I mean, major instability. You got these fluctuations, waves of extra solar wind and density coming in, being thrown in from that planet, in my humble opinion, because if you pull up Discover, there's another thing I wanted to point out. Remember I said the solar wind density, since the solar wind speed's coming way down, the solar wind density should start piling up again, up around ACE at the L1 point, 930,000 miles in front of the planet. Well, so far it hasn't. So I think what's happening is this big planet's having a blocking mechanism, or it's absorbing a lot of the energy coming from Nemesis behind the Earth right now, and it's not piling up, or else it's so big it's just completely blocking the solar wind, and it's not reaching out by the ACE L1 Lagrange points. I mean, it might be reaching out here and out here, but it's not reaching right in here where this ACE satellite's recording, because I think it's only recording on a 15-degree arc. Not sure about the Discover what the arc is. So it looks like I'm running out of time. So we'll pull this through. So remember 2020, that's when the event started, 11:15 2020. So you can see we got a lot of pressure back here, 11:15 2000. A lot of electron volts. That's what the pressure's coming from, the electron volts. Look at that. Okay, that's when we had the big 1145 solar wind speed recorded on here at 2020. There it is, see it? And there it is here. So we'll pull it through the 5 hours. You can see the magnetopause is getting all squirreled around a little bit. There it is there. So it went to 11:16 124. Look at that. Okay, this is when it was just getting ready to pop and send all this energy back out, and there it went. You could see the bow shock reverberated from the concussion or the release. So that's about it. I'm running out of time, unfortunately. Check out the description box underneath the videos. Open up the comment section, hit newest first. God bless, peace, and I'm out.